Hi, hello everyone. Hope you all are doing well with your best effort. This is Sham. Today in this class, actually, we are going to discuss about differentiation, which is again essential for the subject physics in order to solve questions and also deal some concepts. Okay, let's start with a simple way of differentiation. Differentiation is nothing but, for example, I took here one object. Correct now? This is completely one object. If I will piece this one further, okay, it will become divide by 2. Further, if I'll divide means the number of pieces will be going to increase. As the number of the part of the body will be increases means we call this one as differentiation. Means simple, anything is there. For example, here I will take one rod, its length is L. Suppose take its length is L. If I will break this rod here, a small portion, this small portion I can call dl, or else we may write this one as in mathematics what you learned delta l. Delta l is a small change in that total amount. In this dl, I'm expanding this dl. Okay, for example, take the dl length is this much. Okay, in this dl length, I will take further one small part of the body. This is a part of the body, a small portion. This is called small dl. We call this one extremely small. Extremely small segment of the body. Okay, basically this breaking of that object into small pieces, extremely small pieces, this process is called differentiation in order to understand. But in mathematics, what you will say, what is meant by differentiation means the process of finding derivatives of a function. Now, this is function. Okay, this complete body is function. Derivatives means the part which is present inside it, that very small part. What is that small part here? This dl. This process, look at that, the process of finding derivatives here of the function, okay, is called differentiation in calculus. Okay, that is what actually in a standard way we'll define. The derivative is rate change of a function with respect to another quantity we'll call. For example, we'll do one thing. This is actually a function. Function means always we are representing with the word f of x. Like that, we will represent the function. Okay, now that function is nothing but length here. Correct my point. I will take this function as length. Derivative means what is the derivative part here? That is dl. Clear? Going forward, you'll understand each and everything. Function generally we are representing with L. That's all. Okay. And in a short way, if I want to say the word for the derivation or differentiation, the act of showing or finding difference between the things are compared. Difference between the things are compared. We'll get to know that what is this meaning in a second page. Look at it. Here actually I have a function. What is that? In this x-axis, I will call this one as x-axis. This is might be already y-axis. Correct now? Here some slope is there. Correct now? I will take this point A. This is point B. Here x is changing means y also change. That change in y with respect to x. Listen what I am saying. How this graph came by the way, straight line. This graph represent some function is changing in x-axis. For that reason, the corresponding y value also changing. For that reason, you got here a straight line. You got this one from y is equals to mx. By the way, here plus c value is 0 might be. Why? Because it is passing through the origin. Now look, as x changes, y also changes. For that reason, the graph came like this. It says at a value, x1 is, a value of x is x1. At b point, its value will be x2. Okay. And in y-axis, at A point correspond to y1 and B point is corresponding to here y2. What is changing here? Y is changing. This is actually dependent variable y. On which factor? X factor. As x changes, y also changes. Means here the change in quantity is y when x is changing. So shall I write like this? Change of y with respect to x. The function of y is changing with respect to x. We call this one as differentiation. Sir, how to write this one? For example, we'll do one thing. Basically, I will take a triangle. Okay, now this opposite side for this angle theta, this opposite side is there now. Okay, in the slope, we can call this one as delta y. Adjacent side is delta x. Delta y stands for here. Delta y is equals to y2 minus y1. Delta x stands for here x2 minus x1. Okay, now basically we want to define these two functions. Change with respect to x. What is the change here? Delta y with respect to delta x. Correct now? But differentiation, we are not using delta x, delta y. Differentiation means it is very small change. Here change is very bigger one, delta y and delta x. Very small means I will take here one more point. This is a dash, this is b dash. Now if I'll consider here this triangle. Okay, here this length is there now here. We can call this one dy, this is dx. Can you able to distinguish between what is delta y and delta x now? Delta y is larger change. Dy is the same function, small change with respect to small x. Clear my point? Now we can write this change in value like delta y by delta x itself. But this is larger change. So in order to minimize that one, we are actually introducing here dy by dx. Basically, this is actually we call differential equation. Dy by dx. We'll go one by one. There is not at all a problem. Okay. For example, now I'll take here one point. Here actually, d stands for differentiation. Now actually, y is a function changing with respect to x. That's the reason I can write here d by dx. It's a standard differential function. What is changing here? Function. Which function? I don't know. This is f of x. Generally, we call f of x as a function. Here, which is f of x? Y. So I can write this one as d by dx of y. Correct now? Any format you may understand means it is better. In mathematics, you might be learn this one very beautifully, but here I'm saying in that pattern. Okay, in order to execute the function very faster. Okay, good. Coming to the point here. Differentiation of algebraic function, they are saying. For example, now I told differentiation. How to write that one? Sir, it is d by dx of any function you told, f of x. Correct now? This is a format of differential equation. I will do one thing. We'll discuss good questions. Suppose y I will treat as function of x, any function of x. Okay, now I'll say y is equals to, or else we'll go one by one. Okay, I'm taking the function now. F of x is equals to 3x. This is what actually I'm taking function. 3x. Okay, now if it is 3x, now I want to differentiate this one. We need to differentiate. We need to cut this one into as a function. Now do one thing. Standard format is basically d by dx of, that is function of x, right? Or else we can write this one as d by dx of this is y. Correct now? Now, what is y? Y they given is 3x. This is what, right? Simple. What we need to do? So d by dx of, here it should be 3x. Okay, this is actually majorly the function. When you're doing differentiation, there is a particular condition. If this function is differentiating with respect to x, means this function also must and should have the variable x. If it is x and denominator also x, then only you can able to differentiate this. Otherwise, you can't differentiate. Clear my point? Clear? That's all. Now we'll do one thing. Look, here 3 and x both are in combine in a multiplicative manner. Okay, so that I will write this one as 3, I will take outside. It's a constant value. Constant along with the variability scheme. So we'll do one thing. I will not give here 3. No need to be get confused with that 3. Going forward, I will introduce only x is there. What is the value? X. So what do you got here? dx by dx. You need to differentiate this x with respect to dx. Basically, it's a standard. Okay, differentiation of x with respect to x is always be 1. What is that value? 1. Clear? In this pattern, actually, we need to solve the question. We'll go 2 more pattern, then you'll understand clearly. Okay, next we'll go the standard format of algebraic function. That is, I will say here y is equals to x to the power n. Okay, this is very important. Majorly in physics, we'll use this format only in order to solve many questions. Now I need to differentiate this one. I will write this one in a short form. Differentiate with respect to x I told. Then what all you need to do? Simple. D by dx of y. This is a function. What is the function value? Substitute here. D by dx of y value is x to the power n. X to the power n format always has a answer. First shift this power side n. And we need to differentiate this one now. For that reason, you need to write x to the power, whatever the initial value it has n. Along with that, do or subtract here with -1. Original value subtract with -1. This is actually the format of differentiation of x to the power n. So now we can say the dy by dx value came n into x to the power n minus 1. We'll solve one problem, then you'll understand better. Okay, na? For example, now I'll say y is equals to x to the power 2. Y is equals to x to the power 2. Now, if I want to differentiate this one, I will write dy by dx. Means d by dx of y value. What we need to substitute here? X square. Now look how it is, in which format it is? X to the power n. So what all you need to do? Simple. First shift the power 2 and write x to the power n minus 1, means 2 minus 1. So what will be there, your answer here? 2x. Correct? This is how you need to give the answer. For example, we'll go with one more. One more I will take. Y is equals to, this is question. Again, one more question. Y is equals to x to the power 6. X to the power 6. Now tell me how to do that one. Sir, it is differentiation. dy by dx. Correct now? Here we need to put d by dx of function of y. What is that? X to the power 6. Okay. Now we need to differentiate this x to the power 6. What we need to do first? Shift this 6 to down first and x to the power, whatever the value it has, subtract that one with -1. So 6 minus 1. So it will be 6x to the power of 5. Clear? Will you solve one more? Good. Look, Next question. For example, y is equals to x to the power minus 6. Now what we need to do? Same thing. Sir, it is dy by dx. Means differentiation of that function y with respect to the x is equals to, first whatever the power it has, shift that one to left hand side, minus 6. X to the power, whatever the power it has, for that power you need to subtract with minus 1. Then what should be your answer? Minus 6 x to the power minus 7. This is how actually you need to differentiate the algebraic functions. Hope it is understood to everyone. We will solve 2 more questions. Okay. Next question. We'll practice. Okay. First, pause the video after getting question, solve by yourself, and then check the answer. Okay. Y is equals to x to the power 3 by 4. Pause the video and do yourself, and then later cross check by yourself. Now we need to differentiate, right? Dy by dx is equals to, shift the power first, and shifting it should be 3 by 4. Next, x to the power, whatever the power it has, 3 by 4. Okay, in that power we need to subtract with minus 1. Okay, now what should be the answer? 3 by 4 x to the power 4 means 3 minus 4 minus 1 by 4. It should be minus 1 by 4. Correct now? Or else sometimes you may write this one like this also. 3 by 4, its power is minus 1 by 4. If you'll take that whole thing to denominator, then we can write 1 divided by x to the power of 1 by 4. Okay, this is what answer for differentiation of y with respect to x. Clear? Hope you understood and enjoying, right? Then we'll do one more. Next question. If I'll take y is equals to I will take here 4. What I will take? 4. Now we'll do one thing. dy by dx means we need to differentiate this 4 with respect to x. Correct now? By the by, this 4 is actually constant number. What is this? 4 is constant. Okay, constant we can't able to differentiate. Okay, for that reason we are actually choosing constant of differentiation is equals to 0. Keep this point in your mind. So what is the differentiation of 4 with respect to x? It is very simple. Answer dy by dx or d4 by dx value should be equals to 4. Clear my point? Are clear? Good. We'll go with one more question. Okay. Question says here, for example, y is equals to t square. Y is equals to t square. Might be t is also a function of y. Okay. Now again, we need to differentiate this with respect to x, I will say. Oh, it's very simple. Now what we need to do? Sir, it is very simple. Dy by dx is equals to, means d by dx of t square. Did you remember what I told during differentiation? If you are differentiating here with respect to x, this function also must be in terms of x only. Now it is in terms of t. T means we can take time, whatever it might be. Now tell me, is these two are relative? No. Means here t is not function of x. We can say t is not a function of x. So t we should be treat as constant. If it is constant, then the answer for dy by dx should be equals to 0. Done my point? Are you understood? Understood what we written here? Because t is not a function of x. Clear? Okay, that's great. We'll go with one more here itself. Next question. Question says here, y is equals to t cube itself. Same question. Now I'll say differentiate this function with respect to t. T itself. Here t stands for, I will treat time. What I will take here, t as time. No problem. I will give a definition. Means particular function I given time. Okay, where x and y are variable. I don't know which function they are. But here particularly I'm saying t stands for time. Now simple. What we need to do? This time it will be not 0. Okay. dy by with respect to t I told. Means instead of x, what you need to write? T. Next to that. d by dt of. What is y? They given t cube. Now cross check. Here this is a function of t and we can differentiate this one with respect to t. So now what will be the correct answer? First shift the power. Then t to the power 3 minus 1. So answer will be 3t to the power 2. This answer. Means one thing is confirmed. Whenever you're doing differentiation, that power has to be in the format of same thing. Hope it is clear to everyone. Whatever the function it has, the same thing should be in a denominator. Then only we can able to differentiate, other else it is not possible. Clear? Okay, na? Good. Next, differentiation of trigonometric function. We know trigonometric functions, right? Sin x, cos x, sin theta, cos theta. This is also very important, by the way. Okay. Now I will go with y is equals to sine. Okay. First I'll write the trigonometric functions on. Okay. What are the trigonometric functions? Sin theta, cos theta, tan theta, cot theta, secant theta, cosecant theta. These are the trigonometric functions. Now, this is theta. Now I want to take the differentiation. Now tell me what is differentiation, how it is represented. Sir, it is d by dx of any function. That function is taken care by y. Simply we can write y is equals to f of whatever it might be. In this case, theta is visible. So I will treat this one as theta itself. Okay, na? Now I can write this one as d by dx of, what is that function? F of theta. Might be it look like clumsy. Okay, no problem. F of theta is the function. Theta is function. Now tell me one thing. If it is theta, if you'll write here dx, will it be correct one? No, it is not correct. So this is wrong method. Okay, not wrong method. If in this method, if you'll go means for all the values you need to put 0 itself. For example, d by dx of, what is a function? I will treat function also first. In question pattern only we'll solve. For example, I will say here y is equals to sin theta. Okay, now I want to differentiate with respect to x. Means d by dx of the function is y. Now tell me one thing. D by dx of y value is here they given sin theta. Here it is theta. Here it is dx. Is it possible to differentiate? No. What I want to suggest, in the beginning I told like that this is a length L. Length is L. If you'll differentiate, means if you're going to piece this one, the small length will become dl. This is also dl. This is also dl. Means dl are the units of that function L. Correct what I'm saying? Okay. Is it possible to differentiate this with respect to volume? No, volume is different, length is different. Is it possible to differentiate this mass? No, you can't take. Correct. Now, if you want to differentiate with respect to mass, means I have to define like this is total mass is m, the small mass is present here dm. Then dm is the smallest elementary particle like y function of that mass. Mass with respect to mass, length with respect to length, means theta also has to be in the format of theta itself. Then only we are able to differentiate. Otherwise, it is not possible. Correct now? So, in order to write, this is basically wrong. Correct now? If you differentiate this one, dy by dx value, what you will get? 0. Because theta is not possible with respect to dx. Hope it is understood. So how to do this one means simple. Okay, what we'll do simple. Y is equals to sir sine theta. Now if I want to differentiate this one function sine theta, then I need to take here d theta. Khel khatam. Right what I'm saying? So what you'll write here? D by d theta of sine theta. Basically, you need to remember the answers. Differentiation of function sine theta with respect to d theta, answer will be, just I give you. Answer for this question is basically cos theta. Okay now. What is the differentiation of sine theta? Cos theta. Answer is cos theta. First solution, important. Okay, what I given? Y is equals to sine theta. Answer you got cos theta. Similarly, if we'll differentiation understood, right? We have 6 trigonometric function values also. One by one, I will tell you. Please try to understand and keep this all the things in your mind. Okay, first thing, what I told, differentiation of sine theta with respect to d theta, it is equals to cos theta. Next one, second one, differentiation of cos theta with respect to d theta. Function which is here, cos theta function. If you differentiate cos theta, answer it will come minus sine theta. Okay. Next, third one, differentiation of tan theta. Differentiation of tan theta, it will come here secant square theta. Similarly, fourth one, differentiation of cot theta should be equals to minus cosecant square theta. Last two are there. Fifth one, differentiation of secant theta. Its answer is secant theta into Bhagwan tan theta. Sorry, mosquitoes. Secant theta into tan theta. Next, sixth one, differentiation of, here I made a mistake, theta, right? Good. Differentiation of theta with respect to cosecant theta should be minus cosecant theta into cot theta. Okay, might be you got all the answers. Differentiation of sine theta, cos theta. Differentiation of cos theta, minus sine theta. Differentiation of tan theta, secant square theta. Differentiation of cot theta, minus cosecant square theta. Differentiation of secant theta into tan theta. Differentiation of cosecant theta, minus cosecant theta into cot theta. I will tell you how to remember this minus sign. Okay, wherever you will get c, function of c, cos theta. Okay, look here, cos theta will come, right? Cos. In cos, actually, c is there. Wherever c will come, take along with a negative sign in order to remember easily. Okay, next to that, cot theta minus. Next to that, cosecant theta, C minus. That's all. Apart from that, nothing to remember. There is no mnemonic to remember this all that in sign. Clear? Good. Okay, now. Next, we'll go with exponential and logarithm function. For example, similarly, what we studied up to here, what is that? First function, y is equals to x to the power of n. In this format, anything is there. Then if you will differentiate this with respect to x, what you'll get? N into x to the power n minus 1. This is the standard format. Correct now? And the second one, what we discussed, if it is any constant function, any constant, C stands for here, constant. Okay, differentiation of constant will be 0. These two functions we studied. Next, very important thing, if y is equals to e to the power x, e to the power x, if we will differentiate this one with respect to x itself, the answer will be e to the power of x itself. E to the power of x answer will be remains same. There is no change. Clear? This is also very important. Next, we'll come across with one more. That is, if y is equals to log of x, logarithm function we'll call this one. It will come very soon in your syllabus. Try to remember log. Okay, in order to simplify mathematics, like higher derivative terms or else higher power terms, we are using log. Okay, log x. If you will differentiate this with respect to x, then you will get 1 by x. These two are again standard functions for the differential rule. Okay, now try to remember these things. Okay, these are all required for differentiation. What we discussed now, what is differentiation? Okay, next to that, what we discussed basically, look, how actually we need to represent a differentiation term, change in y with respect to change in x. And then we discussed about the function, algebraic function, how they will vary, standard functions. And we discussed about the few formulas, and also we discussed your good numericals. If it is time, then with respect to time. If it is x with respect to x. If it is theta with respect to theta only, we can able to differentiate. Otherwise, we can't differentiate anything. What if in case, in curiosity, I'm asking. Okay, this is last pattern which I will discuss in this video. Y is equals to, if I'll ask sin x, what is your answer? With respect to dx, is it possible to differentiate? I will say, for example, in this case, I will say differentiate the function of y with respect to x, I will say. What all you need to do? Simple. So d by dx of this y. It is nothing but d by dx of y value is sin x here. What is differentiation of sin x with respect to x? How you did in theta, same answer it has to come. Means answer should be my sin x is equals to cos x. This is differentiation. Then if I'll say now, tell me, y is a function of cos x. What is the differentiation of cos x? Dy by dx. With respect to x, I'm doing simple. For cos x, c stand. C, wherever c is there, you need to put minus. So it will be minus sin x. Clear? Now tell me in a faster way. We'll finish one more question. That is, if y is equals to secant x. Okay, differentiate this with respect to x. Simple, sir. Now only you told, like, if it is x means I will write dy by dx. So d by dx of secant x, answer will be secant x into tan x. Answer will be remain same. Where we differentiate theta with respect to d theta. Here we differentiate that x with respect to dx. That's all. Hope you all understood this video and whatever the content I given. In the next video, we'll learn about what are the rules for differentiation and we'll discuss good numericals. Until then, take care. Bye-bye.